What's going on, guys? Let's look at this problem right here. Here's question is asking, calculate V out over V in for each of the circuits depicted in figure 5.142. Here I just took one of the circuit. Assume Is is equal to 8 times 10 to the power of minus 16 ampere, beta is equal to 100 and Va is equal to infinity. Also assume the capacitors are very large. Here if they mention the capacitors are very large, it means the input part can be short circuited. So that's what this means. Okay, now the first thing is we are going to calculate IC. To calculate IC, we are going to apply KVL around here. If we apply KVL, this is going to be VCC minus IBRB minus IERE is equal to VBE. Now instead of this IB, IE and VBE, we are going to create an equation based on IC. Here what we can do is, instead of this IB, we can replace that one with IC over beta, because IB is equal to IC over beta. So this is going to be VCC minus IC over beta times RB minus, instead of IE, we are going to plug 1 plus beta over beta times IC, because both of them are equivalent. IC, because we want to make just one unknown variable, that's why we create this one, and our purpose is to find out IC, because that's what required to find out the transconductance. So we replace this IB and IE with this one times RE, that's equivalent to VBE. Instead of VBE, we can plug it with VT ln of IC over IS. Now let's go ahead and plug all the values. VCC is here, that's 2.5 voltage, and IC is what we are trying to find, IC, and beta is given, that's 100. Divide this by 100 minus 1 plus beta, 1 plus 100 divided by 100 times IC. RE is the emitter resistance. Here our emitter resistance, emitter is here 2K. So this is going to be 2 times 10 to the power 3. Base, this one actually collector, base, emitter. Okay. So this is 2 times 10 to the power of 3. Now we are in this side. Let's go to the other side. VT is a constant value, that's 26 millivoltage. So 26 times 10 to the power minus 3. Ln IC remains the same, and IS is given, that's 8 times 10 to the power minus 16. 8 times 10 to the power minus 16. Now here IC is the only unknown variable, and if you solve for IC, you will get 708.24 microampere. Now we have solved for IC. The next thing is we are going to solve for GM. GM is a transconductance, that is equivalent to IC over VT. IC is calculated, that's 708.24 microampere divided by VT, that's 26 millivoltage. And if you divide, you will get 27.24 millisiemens. This is transconductance. Next thing is we are going to calculate the voltage gain, that's AV, that's equivalent to minus RC over 1 over GM plus RE parallel RC divided by 1 plus beta. Now RC is the collector resistance. In collector we have 1 kilo ohm. That's what we are going to use. 1 times 10 to the power of 3. And then 1 over transconductance. 1 over transconductance is 27.24 times 10 to the power minus 3 plus RE parallel RC. RE parallel RC is going to be 1 kilo ohm parallel with 50 kilo ohm. 50 kilo ohm. And then 1 over 1 plus beta, that's 1 over 1 plus 100. And we multiply the whole thing by this plus right here, and if you calculate this voltage gain, that will give you negative 21.54, and that's our AV, that's our final answer. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.